This theory stuff where you read information and repeat it on quizzes. That's what we just went through. But what most people would rather do is the hands-on projects. So if you go to my page, samsclass.info, and then click CNET 121, and then click Projects, here's all the projects. So the first one is binary. You do have to learn binary. If you're going to be in computing, you eventually have to learn binary. It's as much as we have math in this field, this is the math. So let's start with that. All right, and there's a few of these here. I'm going to start with nibbles. So let's start with the lesson to tell you what nibbles are if you don't know. All right, so nibbles are the simplest binary thing you'd start with. So consider normal numbers. You have 10 possible digits from 0 through 9. So if you write down 147, you're used to the fact that this is 100, 4 tens, and 7. 147. That's what we've all learned and we've gotten used to. So this is the idea. The number on the right is the number of ones, which is 10 to the 0. The next number is the number of tens, which is 10 to the 1. And the next number is the number of hundreds, which is 10 to the 2. So you call this base 10. There are 10 symbols, and this number is 10. Each digit to the left is 10 times more important than the one before it. So that's what you have. Number of hundreds here, number of tens here, and number of ones here. Now in binary, you only have two numbers, 0 and 1. So if you write down 1, 1, that means 1 times 2 plus 1. 1 times 2 to the 1 plus 1 times 2 to the 0. That's 3. So this one on the right is the number of ones, the next one is the number of twos, the next one is the number of fours. So 101 is 5. It's a 4, no twos, and a 1 for 5. So if you want to count to 7 in binary, 0 is 0, 1 is 1, but 2 is 1, 0, 3 is 1, 1, 4 is 1, 0, 0, that's a 4 and nothing else, and 7 is 4 plus 2 plus 1. So that's the biggest 3-character binary number is 7. And if a nibble is 4 bits, half of a byte. So the one on the right is the number of ones, then you have the number of twos, the number of fours, and the number of eights. So this number is 9. 8 plus nothing plus 1. That's 9. And there are only 16 possible nibbles from 0 to 15, and here they are. Here all zeros is 0, 1, 1 is 3, 1, 1, 1 is 7, 8 looks like 1,000. It's 8 plus no 4s plus no 2s plus no 1. This one's easy to remember. 10, 10 is 10 because it's 8 plus 2. No 4s and no 1s, so that's 10. And the biggest nibble is 1, 1, 1, 1. That's 15, which is 8 plus 4 plus 2 plus 1. So that's the simplest binary thing to work with. And I have a little quiz you can do here to get points for it. What you do is you do this thing here, and I'll start it here. Okay, so convert this number to decimal. So what do you think? Anybody got it? Just call out an answer.
11.
What did you say?
9.
All right, 9. It's not 9. It's 7. 1, 1, 1. This is no 8s, 1, 4, 1, 2, and 1, 1. So it's 4 plus 2 plus 1. That's 7. Okay? How about this one? 10, 11. What's that?
11.
Yes, it's 8, no 4, and 2. That's 10. That's 11. 10, 11 is 11. Okay? So now you got one correct. How about that one? 0. Okay. How about that one?
13.
15?
13.
13.
No. 16. Yeah, 14. 14.
All right, now what it is 14, and let me tell you a trick. Even numbers in decimal are also even in binary. If it ends in 0, it's an even number. If it ends in 1, it's an odd number. So it can't be 13 or 15. It's 14. And the reason it's 14 is 8 plus 4 plus 2. And no 0, no 1s. So that's 14. But that's a thing to know. Even numbers in decimal are also even in binary. How about that one?
15.
That's 15, the largest possible one. And that one? 10. Remember that one? Good. All right, so that's the game. And when you get 10 correct, you'll get a flag. So the way these projects work is you get a flag, then you take a screenshot, and you turn it in Canvas. So if you finish this, a flag will appear, just a word to show that you finished it. And then you go into Canvas here, and you will find a place to turn it in here. There, project here. You go in here, and now you can make a submission here. Let's try student view. There, now I see it there. And you can start the assignment, and then you'll be able to upload the image you took, and you can put in comments, or you can say the flag was whatever it is. So we look at the flags to see if you got it right, and if anything's wrong, we look at the image to try to help you. So you do a lot of screenshots in this class to prove you've done the assignments. By the way, some of my advanced students are used to capture the flag contests, which are automated systems, and if you want to do it that way, you can. You'll find submit flags at the bottom here, but if you aren't used to those, which most students aren't, just use Canvas. But that's another way to do it. So all these projects end in flags. So that's Nibbles. And in this condensed session, let me try one more of those binaries here, just as a demonstration. All right, let's go back here. Let's see. Right, let's try bytes. All right, so bytes are the next thing after nibbles. We talked about this, how base 10 works. 147 means you have hundreds, tens, and ones. And in base 2, you have ones, twos, and fours. All right, we've done all this last time up to nibbles, but that's a nibble. But for a byte, you just keep going. So you have ones, twos, fours, and eights, and then you have 16, 32, 64, and 128. So it can get kind of annoying. So this number, 1001, 1001, is 128, nothing, nothing, 16, and 8, nothing, nothing, and 1. So it's 128 plus 16 plus 8 plus 1, and that works out to 153. And it can get pretty tedious adding up these big numbers like 32 and 128. But if you're careful, you can do it that way. This is, by the way, the most difficult way to do it, but it is the way to do it when you're just learning until you're ready to learn the better way, which is hexadecimal, which we'll get to. So let's try a few of these. Again, there's some games to do here to show you can do it. Here's bytes. So can somebody tell me what this is? I put a space in the middle just to make it easier to read. 0100 0101. Okay, I got it. And you might have to like scribble on a piece of paper or something to get it, at least at first. 69. Because this is 128, this is 64s. So it's 64, and this is 5. 101. So 64 plus 5, 69, exactly. So this is 69. Okay, how about that one? Okay, I got it. Yep, 111, because this is 128, there are none of them, but there's a 64 and a 32, so this much is 96, and this is 15. So 96 plus 15 is 111. How about that one? 18, right? Because this is 128, 64, 32, 16. That's 16, and this is 2, so it's 18. All right, let's just read the last one. What do you make of this one? Okay, I got it. That's 123. You've got it. There's no 128s, but there's a 64, 32, and 16, and I happen to know that's 112, and this is 11. So 112 plus 11 is 123. All right. Anyway, that's how this one goes. And by the way, if you really want to get good at this, if you take Cisco, you will have to learn to get very good at this. The Cisco classes here, which are extremely valuable, this is the part that's considered hard, is subnetting, which requires you to get good at binary to decimal, which is not that hard, but it does take some practice. All right, anyway, so those binary games are the first project you should work on. And let me stop this video.